Hello and welcome to R&D Mathematics. Today we are going to talk about zeros of a polynomial. Now actually in last video I was telling you that our goal is to graph higher degree polynomial functions. But in order to do that we have to learn few things first. So one of them is finding zeros of a polynomial. When I say zeros, actually real zeros, because some of them are complex roots, so only real zeros. Now, one thing you need to remember, I think you already know this, but let me put it in this way. Solutions of f of x equals 0 is equivalent, is same as x-intercepts and is same as zeros of the polynomial. Now, what do I mean by that? Let's see an example, then you'll understand. You already know about quadratic functions, right? Quadratic functions are degree 2 polynomials. So let me take a simple quadratic function. Let's say, how about x squared minus squared plus x and minus 6. X squared plus x minus 6. Now, if this is the function, the zeros of polynomial means the values where f of x equals 0, which means from here we have actually, when you make f of x 0, you have this quadratic equation. Now you can either solve this quadratic equation using quadratic formula, or you can use factors. There are factors, right? So 2 and 3x plus and minus, yes, that will work. So x equal 2 and x equal -3. So 2, 1, 2 somewhere here, 1, 2, 3 somewhere here. So this guy and this guy, those are our solutions. So, and you know, because of this number here 1, it opens up, so roughly speaking you will have a shape like this. But anyway, so in this case zeros are 2 and 3, and they are the solution of f of x equals 0 and also x-intercepts, right? I think that's clear. Now let's take another example. How about a little bit higher degree? Now again, in general, there is no way to solve for cubic or fourth power equations. Depending on the question, you have to, using your knowledge, you have to do something. Now to find zeros of this one, let's set f of x equals 0. That means we have x cubed plus x squared minus 2x equals 0. Now this is a cubic equation and you don't have any general technique. Factors is your best bet. So I can see factors. I can take 1x out, then x squared plus x minus 2 equals 0. So this breaks, either x is going to be 0 or x squared plus x minus 2, that part is 0. So from here x equals 0, you have one solution, and from this guy I think we have factors. Let's see, x, I need 2, so 2 and 1, and I need plus and minus, so here plus, here minus. I think that works, right? So x equal 1 and x equal -2. So actually, how do we write this down? Zeros of this function, so zeros of fx is same as x-intercepts, is going to be x equal -2, 0 and 1, these three places. That means in future when we are trying to draw the graph, we know for sure our graph will go through this point, and this point, and we don't know yet how. It can be like this, and no, not like that, sorry about that. So like that, maybe like that, we don't know yet. So that's what we are about to find, and we are heading there. Now the next thing is, multiplicity of a 0. So multiplicity of a 0. Now in simple words, that means, you know, if x minus a raised to n is a factor of of x, then a, this guy a is a, see, I'm using a for a and again as English letter a. So you know what, let me change this to b. So x minus b is a factor of f of x, then b is a 0 of multiplicity n. Now let me simply explain this going to the previous page. Now look at this function, and we know this function can be written because of these factors, you know, even though we have 0 right hand side, still the factoring is valid. So x minus 2, x minus 3, right? And the power here is 1 and here is 1. So, sorry, x plus 3. So 2, we noticed 2 and 3 were 0. So 2 is a 0 with multiplicity 1 and negative 3 also 0 with multiplicity 1. That's simply what it means. Now let me go to the next page. So if after factoring, if you had something like this, then, you know, just get used to this. If after factoring, if you had this, then what are the, first of all, what are the zeros and what is the multiplicity? Multiplicity, you know, let's make this simple table. You know guys, sometimes in mathematics tables are really helpful rather than writing sentences. So 0, 7, x minus 7 means 7 is a 0, not negative 7. X minus 5 is 5 is a 0. X plus 1 means negative 1 is a 0. With multiplicity is 3, 1 and 2. Because these numbers that appear here. Right, that's simply the multiplicity, the meaning of multiplicity. And also something else, you know, in future we are going to divide polynomials, but one thing, what was the, let me take x squared plus x minus 6. We took this example, x squared plus x minus 6, right? And let me show you something. So this happened to be x minus 2x plus 3. So we know 2 and negative 3 are zeros of f, right? One more thing to show you guys here. Whenever, see, if b is a 0, that means, i.e., f of b is 0. If this happens, then for sure x minus b is a factor. Look at this example. See, 2 is a 0, x minus 2 is a factor, negative 3 is a 0, x minus negative 3, which means x plus 3, is a factor. It always happens. Why? Can you think why? Because, see, when you plug f of 2, what you get? 2 minus 2, 0, right? And when you plug f of 3, what do you get in this function? Again from, no, sorry, negative 3. When negative 3 goes there, 0, right? So that will always happen. So remember this part, this is really helpful. Now that's the definition of multiplicity. Now we have some theory part. Now with this multiplicity, something really nice will happen. So multiplicity of a 0 and relation to the graph. So this is the thing that we need to learn. So multiplicity, again a table. So it can be even multiplicity or it can be odd multiplicity. Now, if the multiplicity is even, what will happen is our graph will touch. So touch and go, touch the x-axis. So let's say multiplicity of b graph will touch x at b comma 0, and if it is odd, graph will cross the x-axis, here also x-axis, right, x-axis at b comma 0. Now what this means is this. Now let me show you. For example, let's say you have function f of x like this: x minus 1 squared, x plus 3 over 5th to the 7th, and x plus 5. Now first of all, what are the zeros? So zeros with multiplicity. Zeros are 1, negative 3 over 5, and negative 5, right? And multiplicities are 2, 7, and 1. Now what will happen? At this point we know, with this table we know, with the help of that table we know, okay, zeros at negative 5 somewhere here, let's say negative 5 comma 0, and negative 3/5 somewhere here, and 1 somewhere here. So multiplicity, this guy, multiplicity 2, that is even. So our graph will touch it either like this or like this. We don't know yet, right? And other two are odd multiplicities, so either it will cross like this or it will cross like the other way around, like that. We don't know, but it will cross. Now let me ask you, can you see why when it is even it cross, and why when it is odd it touches? It's easy, guys. Now let me explain that. Even, let's say even, and let's say you have x minus 1 squared, something like this, f of x equal x minus 1 squared, and some other terms, blah blah blah, x plus 3 to the cube. Let's say this is the function. Now zeros are 1 and negative 3, so 1 and negative 3 somewhere here. See, if you take a number close to 1, let's say 0.75, when you plug here, right, because of this one, when you plug here 0.75, and for sure there are no other zeros in between these two values. There are no other zeros. Now listen carefully, guys. What I'm explaining can be verified using some differentiation and stuff in calculus, but without those stuff, with your knowledge in college algebra, you can understand this if you listen carefully. So there are not any other zero in between this. So if I plug 0.75 minus 1, yes, that value is minus, but because of this 2 or even number, I get a positive value, right, somewhere here. And if I find some value very close to this side, from 1.25 minus 1.25, again the same value. See, points will always take same same parity, or say it will be always in one side of our line if you have even root. I mean, it's not necessarily going to be on top. It can be like this, because if there is a minus sign like that, things will happen. But what you need to understand, when you have an even power, the points which are close will never be of opposite parity. That's why here it touches the x-axis, touches and turn around. But on the other hand, if it is odd, what will happen is, if I take two numbers close to this, one will have positive and one will have negative, or the other way around. So it will like this, or it will like this. So I hope that part is understood. And then, yeah, so I think that's enough examples for today's lesson. So zeros of, let me quickly summarize. So a zero is known as a solution or root of, or see root, another word, of f of x equals 0. Those are the x-intercepts, and those are the zeros of polynomials. And then we learn this word multiplicity. That's simply this power when we factor it. And if x minus b is a factor, always b is a 0. So remember, x, for example, x plus 5, you have a factor like this. 0 is negative 5, not positive 5. And depending on the nature of that multiplicity, if it is even, it touches. If it is odd, it crosses. Now this is really helpful. And one more step to be done, and then we can graph higher degree polynomials. Thank you.